Hi everyone, welcome to my YouTube channel. So in this video I am going to solve some of the previous year question papers of classical mechanics. So before going to start, if you are new to my channel, please subscribe my channel so that you will have the information regarding upcoming videos. So let us start. So the first question, Hamiltonian canonical equation of motion are. So this question has been asked many times in the previous year exam, so very important as per your exam. So as we know, Lagrangian is represented in terms of canonical coordinates q dot comma t, that is velocity component, whereas Hamiltonian q comma momentum p comma t, so time function of q p comma t. So if we solve the Lagrangian and Hamiltonian, we will get the canonical equations. If you observe the option C, if you see qi dot, that is equal to dou h by dou pi dot is equal to dou h negative of dou h by dou qi. So this is the correct answer. So the Hamiltonian canonical equations are given by option C. So the next question, Jacobi identity for Poisson bracket. As we know, Poisson bracket we can write in terms of notations A, B, C or X, Y, H. Here they have taken. So the sum of these commutation relations are going to be equal to 0. So if we see all the four options, the option A is correct. Okay. The next question. So the next question, the value of m and n for which the transformation are q, capital Q equal to q to the power m cos np, p equal to q to the small q to the power m sin np represents the canonical transformations are. So the option, you can see the option, then try to solve the answer. So let us solve this question. So as we know, commutation of q comma p is equal to 1, and if we, so let us try to solve this question. As we know, the commutation of q comma p is equal to 1. Q comma p is equal to, we can write the derivative in terms of this equation, dou q by dou qi, dou p by dou pi minus dou q by dou pi, dou p by dou qi. Then what we have to do, according to the given question, we have q equal to q to the power m cos np and p equal to q to the power m sin np. If we take the derivative of this q and p according to this given equation, we will get dou q by dou qi is equal to m q to the power m minus 1 dou p by dou qi is equal to m q to the power m minus 1 sin np. If we take derivative with respect to p, dou q by dou p minus q to the power m n sin np dou p by dou pi is equal to n q to the power m cos np. So if we use these four equations in this commutation of q comma p, we will get final equation as m q to the power m minus 1 cos np n q to the power m cos np plus q to the power m dot n sin np into m q to the power m minus 1 sin np equal to 1. Okay, just observe this equation, then which implies m n q to the power 2m minus 1. We can take cos square np plus sin square np. We can multiply and we can take here mn common to the power q to the power 2m minus 1. So here m that is 2m minus 1, and this is cos square p plus sin square p equal to 1. As we know, q comma p is equal to 1. Then we can write as q to the power 2m minus 1, that is cos square plus sin square is equal to 1, which is equal to 1. So thereby we can have here mn is equal to 1 from the given options. If you take 2m minus 1 equal to 0, then we will get the value of m and n, that is n equal to 2, m equal to half. So the correct answer for this question is n equal to 2, m equal to half. That is here the option B is correct. Okay. So the next question, a spaceship is traveling with a velocity 0.4 c, where c is the velocity of light. A person performing an experiment in this spaceship observes a particle moving with a velocity 0.4 c in the same direction as that of the motion of the spaceship. A stationary observer on the earth would observe the particle to have the velocity. So what is the velocity of the observer we need to calculate. So let us solve this question. So here, as you can see in this question, they have given the speed of spaceship, that is 0.4 c, and speed of particle, okay, that is also 0.4 c. Okay, so just you can take speed of spaceship is equal to 0.4 c and speed of particle is equal to 0.4 c. You can just denote it by u, small u, and this by v. Then the speed of observer, the speed of particle observing by observer, we can write the speed of particle that has been observed by observer, that is equal to, we can take this as u prime, that is equal to u plus v divided by 1 plus uv by c square. So as we know from this question, the speed of spaceship 0.4, speed of particle 0.4, 1 plus 0.4 into 0.4 divided by speed of c square. So here we get 0.8 c divided by 1 plus 0.16 c square divided by c square. So c square get cancelled. Here we will get 0.8 c 1.16. If we divide these two, we will get u prime, that is speed of particle with the observer is 0.69 c. So the correct option here is A. So the next question, very important. A massless spring of force constant K has masses m1 and m2 attached to its two ends. The system rests on a horizontal table. The angular vibrational frequency omega of this system is. So among these four options, you need to find out the correct answer. So let us solve this one. So according to the given question, the massless spring of force constant K has masses m1 and m2 attached by string. Let us take this string attached by mass m1 and m2 having the coordinates q1 and q2. Then the kinetic energy, we can write it as or we can take capital T, half m1 q1 dot square plus for two masses half m2 q2 dot square, half mv square, that is velocity. Then so that the matrix of this kinetic energy, so that matrix is diagonal, then we can take here for diagonal matrix only the diagonal elements are having the values m1 m2. Okay, then the potential energy, how we can write the potential energy here. So the potential energy is given by V is equal to half KQ2 minus Q1 square. Okay, spring constant K, subtracting the position coordinates Q2 minus Q1 square. Then half K into, if we square it, we will have Q1 plus Q1 square Q2 square minus 2Q2 Q1. Hence V matrix has the form, potential energy has the matrix form as V is equal to coefficients of K, or K, in terms of K we can write minus K plus K. Okay, so we can represent potential energy like kinetic energy in terms of matrices. If we write in terms of matrices, we have to take here coefficients of Q1 square Q2 square, they are positive, and if we take Q product of Q1 and Q2, we will have minus K for the negative sign. Then combining these two matrices, if we combine matrix of V and T, we will get V minus omega square T is equal to K minus omega square m1 minus K minus K minus omega square m2. Okay, as we know, T is equal to what? M1 0 m2. So if we combine these two matrices, then we will have in this form V minus omega square T. So with the solution, if we that determinant is equal to 0, if we multiply the diagonal elements, we will get m1 k minus omega square m2. This will be plus k square. Minus minus plus, but again we will have minus sign, so k square equal to 0. If we multiply these inside the bracket, we will get k square minus omega square m1 k omega square m2 k plus omega to the power 4 m1 m2 minus k square. So if we observe this equation, we can just simply cancel these two, and remaining will be m1 k minus m2 plus m2 k minus omega square m1 m2. We can take omega square common and divide it by 0, then we will again have the 0. Then omega square is equal to what? K into m1 plus m2 by m1 m2. So if we take root of this, we will get root of k m1 plus m2 by m1 m2. So the correct option here is option C. So this question is very important. Many times it has been asked. So try to solve this question. So the next question, a sphere rolling down from the top of a fixed sphere is an example of. So the one of the important topic of classical mechanics is constraints. Constraints are what? Limitations to the system. So we have different types of constraints: scleronomous, holonomic, non-holonomic. Okay, so among, you need to understand scleronomous, which is dependent so on time. Non-holonomic is quite opposite to the scleronomic. So in this question, if you read the question carefully, sphere rolling down from the top of a fixed sphere is an example of. If you see the options here, conservative system, scleronomic, only holonomic, this is not valid. So these are valid, and along with this is non-holonomic. So option A is correct. Many questions have been asked on constraint. Compulsory one question will be there on this constraint, scleronomic or holonomic. So try to read that also. So how many degrees of freedom a rigid body possesses? So as we know, rigid body is what? A system of particles which the distance between any two particles remains fixed. Okay, the distance is not going to vary between two particles. So if we consider any of the three particles, p1, p2 and p3, then of a rigid body, then each particle has 3 degrees of freedom here. 3 degrees of freedom, and each particle along with 3 degrees of freedom have 3 constraints. Okay, then the degrees of freedom for these particles we can write as 3 cross 3 minus 3, that is 6. So the degrees of freedom for a rigid body is option C, that is 6. So a particle of mass m moves in a plane, its motion defined by r, t, under the influence of a force F equal to minus kr directed towards the origin. The Lagrangian of the system is given by that is half. Just observe the options given here, so we can solve this question. So the kinetic energy of the system, if we take, that is given by T equal to half m r dot square plus r square theta dot square. Okay, then according to the given force, that is nothing in terms of potential, if we write potential energy V is equal to minus F dot F into dr. Okay, then force is what here? Minus kr. If we integrate this, we will get V is equal to k r square by 2. So Lagrangian is what? Is equal, L is equal to what? Kinetic energy minus potential energy. So kinetic energy is what here? Half m r dot square minus, plus half m r square theta dot square. Kinetic energy, then potential energy after deriving this force F. So the correct option here is option A. So the next question, the Hamiltonian corresponding to the Lagrangian. They have given the Lagrangian, you should find out the Hamiltonian for the given equation. Ax dot square plus by dot square plus kx minus kxy is. So the options they have given, let us try to solve this. Solution. So L is already given, ax dot square plus by dot square minus kxy. Then here momentum, canonical equations, px equal to dou L by dou x dot square with respect to x dot square. If we write, what will be with respect to x dot square? That is 2a x dot. Okay, similarly py is equal to dou L by dou y dot, that will be 2by dot. Then this must be x dot, okay, not x dot square. Then Hamiltonian, in how we can write in terms of Lagrangian, that is summation pi qi dot. This is the very important equation, you should remember, pi qi dot minus L. We have the Lagrangian L, then we have to find out here h, that is equal to what? Px x dot minus plus py y dot summation. If we remove, we can write it as in terms of x and y coordinate, that is ax dot square plus by dot square plus kxy. Okay, Lagrangian if we substitute, then we will have 2ax dot square plus 2by dot square minus ax dot square minus by dot square kxy. Okay, if we substitute value of px and py in this equation, we will get this. Then if we subtract these two, we will have ax dot square plus by dot square plus kxy. Okay, Then here if we write x dot from these two equations, 2ax dot 2by dot, x dot is what here, px by 2a, y dot that is py by 2b. Okay, then what we have to do here, Hamiltonian h, we have to substitute x dot and y dot values. A px square by 2a plus b py by 2b py square plus kxy. So the final equation that we will get here is Hamiltonian h is equal to px square by 4a plus py by 4b. So here square is there, so you need to square it, x dot square, then kxy. So this is the correct answer. Here option, which option is correct here? Option C. So like that you should solve questions related to classical mechanics. These questions that I have solved has been asked in previous year exam, so please try to concentrate on them. Hope this video is helpful. If this video is helpful, please like, share and subscribe my channel. Thank you for watching.